I mean, the beginning of why you will get some mysterious segmentation fault. Okay? So what's this program is about? This program, I have a hello string. Now, there is one thing that I want you to understand. The thing is like this. Yeah, I cannot hold this quick, okay? So I need this assistant. So what is the problem? The problem is, now let's see a program called constant.c. Okay? So let me ask you one thing. So I call this string 2. Are these two lines equivalent? This one, and string 1 and string 2, okay, string 1, okay. Yeah, I will save the file so that I can still compile it. How's that? Any problem? Any difference between these two guys? I won't give you too much time. Just to give you how many minutes, okay, won't solve the problem unless I compile the program. Who thinks string 1 and string 2 are equivalent? 1, 2, 3. Okay? So, if you think that they are different, what are the differences? Well, what are the differences? Yeah, this is a very, how to teach this, right? But basically, you have to think of a difference between string 1 and string 2. String 1 is just an address storage, okay? A storage of 4 bytes, which supposed to store an address. Okay, this is a string 1. String 2, what is string 2? String 2 in terms of a C, we just declare an array, and we don't know how large it is. And to define how large it is, the string length plus 1 is size. Right? String length plus 1, because we have a null determinator, is a size. And it's by magic, if you write string 2, the string will be just like doing string copy and copy into the memory. Okay? Now I show you the first version using the string 1 notation. Okay, I use this to compile the program. Make constant. Now, still show you. Still show you the program. Okay. Now, when I run it, now can you see that I can compile successfully, right? No problem. So why I guess there will be a problem? Because the problem may arise in the line. In my problem 1, line 5, right? If you stay with what I just said, I said that the string 1, that is meaning that string variable is just a variable storing an address. Okay, nothing more. And what is the notation of string 4? Okay, the square bracket and the 4. Okay, if you understand C, it means that okay, I treat the pointer as a starting address of an array of char. That means that I go to the 5th, okay, 0, 1, 2, 3, 4, the 5th slot, and try to modify, right? So by the program, you know that string pointer point to a string constant, a string constant. It's supposed to be a constant, so I shouldn't be able to modify this, right? But the compilation, I pass. How about when I run it? When I run it, go. Yeah, don't care about the time, okay? The time, I don't know why there is delay, okay? But it shows you some error, okay? So I just want to verify, after I do this copy and paste, okay? I do this seems to be copy and paste, but it's not, right? Look at the pointer. Okay, oh, it's kind of ugly here. Okay, so where's my laser pointer? Okay, So I just print out the two addresses. The first address, I directly put the hello here and print it out. This is the address. And then I print out the address stored inside the string. It also tells you the same address. So what's the meaning? The meaning is string point to a constant called hello. And why it gives you 17 ports? It's not because of this, not because of this, but because of this line. I try to modify a read-only segment. Constant is read-only. If you try to modify that, okay, it will give the CPU will give you segmentation ports. Understand? Understand? Now, this is extra. Okay, I didn't put it in the PowerPoint. Okay, I modify the program now. I change it into this way. Okay, I just change 3 bytes. Remove 1 byte, add 2 bytes. Okay, and then compile the program. It won't complain. Show you the program. Now go. Why? Can you explain? Give you a hint. I print the to statement, the pointer statement, on purpose. I want to show you something. Can you remember the previous version? The previous version, I show you the 2 pointer address, they are the same. Now the 2 pointer address, they are different. They are different, totally different. Okay? So what was your answer? I can't say it's malloc, but it's kind of allocated on a local variable. Okay? Malloc is different. Okay? Can you see this? Totally different. The memory space that being allocated are different. This hello, the string is still something like this, right? I execute my old version. Here's my old version. Old version over. Ah, yeah, it's gone. Okay. How can I keep the old version? Oh, no problem. I copy another program. Okay. So make constant 1. Change it into this. Make constant 1. Okay. So the constant 1 give you this. The constant give you this. So the constant 1 is using pointer. Constant is using square bracket. Totally different. And the result is 1 will give you segmentation, 1 not. Okay? So what is the difference? The difference are previously the constant 1 program here. I show you why. Because they point to the same address and the constant supposed to be read only, you cannot write. So give you segmentation port. And what is the program here? With the square bracket. Yeah, as a girl here already answered me. Yeah, it's kind of doing some memory allocation. Right. Here, it means kind of a dynamic allocation and how to allocate it based on the length of the string. They allocate you space, and now you have the space, and the next step is to do string copy. Now this is all done by the compiler itself. Copy into this string array. So that's why when I print this content out, it's telling you 2 different addresses. At least it's telling you that this guy is this guy, totally different, or different memory zone. And here it means inside the local variable. Okay? I don't know how many of you have this practice. Okay? Maybe you already have this practice by default. Okay? And suddenly some people ask you, hey, what if I change your pointer? You suddenly get lost. Why? Because you get substitution fault. And this is why. Here is doing memory allocation. You have new memory, so you are modifying that memory because of this line. You just melt memory on the local variable. It's not the memory on the read-only song. So the memory modification is allowed in this case. Okay? So this is a little bit hard, but I want you to understand only one thing. Why sometimes you have segmentation fault when you're doing string processing? Because you didn't allocate memory. This is the first problem. And the second problem, you didn't allocate memory plus you try to modify read-only song. Yes? Good questions. Okay, Stanley asked me one question is I basically read two constant here. Two constant are both hollow, and they guarantee to be the same. Okay? Clever compiler will locate identical constant and make it into one. Okay? But I don't know how about let's say the Visual Studio. Will it do the same thing? I don't know. Okay? But the meaning here is as long as I modify constant, I will get some faults. And his question is one more level up, that whether these two constants are the same. If they look identical, let's say that these two, of course, these two are identical, C compiler will make it into the same constant. Okay? Did I answer your question? Yes?
Why the second line will point to a constant? I mean, I didn't specify any.
Right, there's another trick that I play in this program. Very good. Now this is constant, right? Suppose I cannot modify constant. And why I make this special assignment statement here? Because I want to get past the compiler. The compiler can be fooled by me. Why? This is constant. And here I didn't say that this is a constant pointer or a pointer points to some constant. I didn't say that. I make it on purpose that I try to assign like this so that I can make the next step modification get through the compiler. Yeah, I'm doing it on purpose. Yes?
If I use this address and read the value of up to this address one byte by byte, then will I read out the program?
I break your question into two. The first one is I do a read-only operations and go through it indefinitely. Of course, I will hit certain barrier that I cannot go through. Now, the second question is that I want to break because you didn't say whether I want to go up, that means increasing address or decreasing address. Now, if increasing address, if you read the direction is increasing, this is already in the map. So if it's increasing, then I will enter the global variable zone and then enter the heap. I don't know whether I have a memory allocation inside heap. Let's say no. Then once I enter the heap, I will get some initial faults because I don't have any memory allocation. Now for the downwards, another way, when I leave this code here, is some area that I reserve. Okay, later on I will tell you what the reserve area. Once you leave the code area, then you will get another segmentation faults. Yes, both ways will get segmentation, but the length is different. Any problem? Yes?
Actually, I think the two versions of assigning hello to string is quite the same to me, but why? I don't know why the compiler will treat similar. Yeah.
I show you the later version. This is the later version, right? You think that the later version is the same as the first version. Yeah,
nothing to me is quite the same.
The main problem is, basically why I know that because I decompile the program and understand this. And this statement is not a simple statement using the pointer to point to that constant. This statement is, I basically can classify in several steps. First, allocate a pointer starting location, then detect how long the string is, and try to allocate space for this array. Let's say here is a 5 characters, so you need 6 bytes. So I allocate 6 bytes to this guy. And the next step is interesting. The compiler call string copy. Yeah. Yeah, there's something really hidden. The compiler calls string copy to copy this guy to this guy. So then later operations here is already a copy versions of the data. Yes.
So this is actually compiler dependent.
Sure. Any problem? Yes?
Is there going to be a zero appended to the constant?
Sure, yes. This is just a string. So I can print it out using processing. So there is a 0 added in the end. Oh, by the way, whether it's a 6 byte or not is not the question. Maybe it's trying to allocate more than 6 byte. But always have a safe location with the byte 0. Any questions? Yes?
Is there any way to try and cache
Get
segmentation?
it here. Yes?
Is there any way to try and cache segmentation?
You want me to try?
No, I mean to try and catch the segmentation.
You can capture the signal, you handle it, no problem. But once you handle it, you cannot do anything more because when you finish the handler, then you will keep on telling the report. You can try. Any problem? Yeah. This program is, maybe quite shocked to you because, very people write in this way. I observe some of your programs. Very people write in this way. Many people write in this way. And that's why you cannot distinguish the problems. And basically, the problem is one with allocation and string copy, one without. Okay? And the without version just point to a read-only area and boom. You write the read-only area, CPU gives you a warning called, not one warning, an error, called segmentation points. Okay? And this program is, I would say that I just do some crazy stuff. How crazy is this? Very crazy. I try to do another thing. The first thing I change is the constant. I try to modify the constant. Now I try to modify another thing. The main method itself, which is the code. Can I change the code? Okay. If my program can modify myself, wow, it would be fantastic, right? Yeah. Look at that. What I'm writing. So what is this? What is this? Line 2 and 3? Line 2 is quite crazy. Huh? I use a void pointer, which is called generic pointer. I can point to whatever things I want. Okay, generic pointer point to the function. Okay, that means that I have a pointer function now. And what's next? I cast this function. Okay, the head of the functions using a char pointer to cast it. So why we need to cast it in the char? Okay, many people ask me a lot. Okay, every year people say, oh, why are you using char? Why cannot use integer? Basically, I want to access a function body, function code byte by byte. So I use char. And why assign it? Why assign it? Because I may find character which is bigger than 127. If it's bigger than 127, using signed notation, it becomes negative. So I use assign. Okay. So if you don't get what I've said, go back and take out your notes of ENTG 2020. It's 2020. Yes. That's the digital logic. Okay. It should teach you what is the choose complement notation. Yeah. Okay. So here, what I'm going to try, I tried 2 operations. If you understand what this statement is about, this statement is point to the functions and grab a first byte. Okay, take out the first byte. Now I try 2 operations. One operation is read it. Can I read the function body? Second, I try to modify it. Can I modify the function body? Okay. Now this is dangerous act. I directly point to the function body, and the function is the main itself. Now let's go. Make a what is the program name? Oh, access code. I want to access my code. Okay? No compilation error. Oh, you want to see the code, right? Yeah, still the same thing. Now go. So what is the result? The result is very simple, straightforward. First, because this is a pointer pointing to the code is supposed to be read only, so I can read it, but I cannot write it. Just like constant. Okay, so why I need to show these two examples to you? Because sometimes you have a problem with your code, and your code just have a pointer, okay, a random number actually. There's a bug, okay. The pointer is not to be a correct pointer. Somehow that pointer address point to this code range or the constant range, okay. And what will happen if you try to write it? Segmentation fault, okay. Any question you want to ask? Any questions? So this is answers. To studies questions to constant kind of unique. Okay, if the compiler is careful enough. Okay. Any questions? No. Then I give you another shocking experience. The data segment. What is a shocking experience? How many of you have used static variable? Okay. Okay. So I ask you, where do you use static variable? Where do you use? Writing classes. Wow, you're talking about job. Okay. So how about C? C, did you use static variable? No? Okay. How did you use C with the static variable? C++, still okay, still okay. Where did you use it? Only classes. How about you? Initialization within which area? Function. Inside functions.
No, I have a function call which need to first initialize by another function call, but I just want to.
Okay, so you hide those names inside functions. Once you call a function, you will initialize it once, and then you can use it forever.
Yes, if I recall the initialization, it can read the static variable and then.
Yes, yes. So he should say the very classic way to use static variable. Static variable usually hiding in functions with initialization value. Once you touch that function once, you won't use the initialization code again because you just initialize it once if it's a static. Now, I will tell you what exactly is static variable. Okay? So, data. Okay? Data is a piece of thing that usually we call it a piece of memory that you can hard code. Okay, so what is the memory that you can hard code? Like you want to hard code array values. Okay, you want to hard code. Let's say that you didn't see this kind of program. Okay, I see a lot. Okay, during my age. Okay, I play a lot of small games. Okay, those games are in the Nintendo. Okay, I know that those programs is just hard coding the map, hard coding the game constant. Okay, inside some global variable. Okay, and when you do so, okay, basically you need to initialize them and put it inside the data range, or we call it data segment. Okay, another version is just give it a name. Okay, usually I just mix the terms. The BSS, okay, don't call it BSS, BBS, okay. The block start by symbols. What is it? It is a range, okay, also global variable, but the variable's value is not there. Okay? Just allow the C compiler to set the default value, or the C compiler don't set any default value when it's being initialized inside a program. It's just with some global random values. Okay? Now, what is this program? What is this program? This program is, well, I have a global variable, okay? I have a local variable. I have a local variable with static. 3 variables. I print them all. Okay, I print them all. And let's see the results. Now first I need to compile a program. Where's the file? Global reader static. Now when I run it, take a look at the addresses. Okay? Now one is a BF something, the two remaining is a X0 something. So kind of match the values here, right? Kind of match. And the difference here, later I will emphasize it. Now look at this program output, because it's more easier for me to illustrate. Look at here. The two variables here, the latest two, the latest two, one is the static variable, one is the global variable. They stay together. Then what's the meaning? The meaning they are within the same area. Okay? And what's happened to the topmost one? The topmost one with a bigger address, which is far beyond this zone and go into the stack. So local variable stay in local range. Local static variable go to global range. Okay? Now imagine back how you use global variable, how you use static variable. Are they having the same kind of behavior? Yes. They behave just the same. You inside a function, you have a static variable as if it is a global variable being jailed inside the function. You cannot use outside the function, but the status is global variable. Just the compiler tricks. The compiler cheat you. The compiler try to put that little global variable into a zone outside the function you cannot use. And this is the truth about static variable. It is global. Okay? Yeah, so by looking at the address, you can learn a lot. Okay? So, I have to stop for a while, okay, because why I look